1.2. The Mule Project. The Mule Project was started with the motivation to make life simpler for developers of integration applications. A major driver for the project was the need to build a lightweight, modular integration solution that could scale from an application-level messaging framework to an enterprise-wide, highly distributable enterprise services bus. What's in the name? After working on a couple of bespoke ESP systems, I found that there was a lot of infrastructure work to be done before you can really start thinking about implementing any logic. I regard this infrastructure work as donkey work, as it needs doing for every project. I preferred mule over donkey, and ass just didn't seem right. Smile. A mule is also commonly referred to as a carrier of load, moving it from one place to another. The load we specialize in moving is your enterprise information. Ross Mason, co-founder of MuleSoft. Mule's core is an event-driven framework combined with a unified representation of messages, expandable with pluggable extensions. These extensions provide support for a wide range of transports or add extra features, such as distributed transactions, security, and management. Mule's developer-friendly framework offers programmers the means to graft on additional behavior such as specific message processing or custom data transformation. This philosophy has allowed Mule to quickly adapt to and support emergent trends in enterprise computing, such as NoSQL, distributed memory grids, and lightweight messaging protocols like AMQP and ZeroMQ. This orientation towards software developers helps Mule to remain focused on its core goals and to carefully avoid entering the philosophical debate about the role of an ESP in an integration scenario. Although Mule is often billed as an ESP, and can be used in such a fashion, the framework makes no dictation on the architecture of your integration applications. Moreover, Mule was conceived as an open-source project, forcing it to stick to its mission to deliver a down-to-earth integration framework and not to digress to less practical or broader concerns. Finally, the strategic decision to develop Mule in the open allowed contributors to provide patches and improvements, turning it into a solid and proven platform. Mule 3, released in 2010, represented a significant departure from Mule 2, on which the first edition of this book was based. The most noticeable differences reside in new configuration mechanisms that aim to simplify Mule configuration. Most specifically, the introduction of the flow construct frees the user from the rigid service-based configuration model of Mule 2. Flows allow the free composition of message processors, contributing to the prodigious simplification of the often verbose XML configurations in Mule 2. Mule Studio, introduced in 2012, further simplifies integration application development with Mule. Mule Studio is a graphical, Eclipse-based development environment. Among its features are drag-and-drop composition of flows, full XML round-tripping, and the ability to run Mule applications directly in the IDE or deploy them to a server or to the cloud. Extending and developing for Mule has also been greatly simplified. Mule Dev Kit, which we'll cover in depth in Chapter 13, makes it easy to write custom Mule components that fully integrate with the Mule ecosystem. Annotations have also been widely adopted by the framework, simplifying the development and testing of these components. Cloud connectors streamline integration with remote APIs and platforms. A new deployment model trivializes packaging and deploying Mule applications. The configuration and developer simplifications in Mule 3 are complemented by incremental changes to the framework. Expression evaluation has been standardized by the Mule expression language. REST support is now native and is coupled with support for JSON.